Okay, let's get started. So for the agenda today, happy Friday. We need to complete the notes of graphing secant and cosecant functions. And then if there's homework questions, I want to make sure that we have enough time for that because we didn't really last class. And then just a reminder that there's an Edmodo quiz that's due Sunday night. I switched it from Saturday to Sunday just because I didn't get up as soon as I had wanted to, on a tangent and cotangent functions. So definitely if you have homework questions about that, let's get those answered before you take the quiz. All right, so these are the notes that we are talking about, and this is the work that we did last class, where we graphed the secant parent function, and then we graphed the cosecant parent function. So just wanting to highlight that the secant parent function is these branches here, and that comes off of the cosine function. But you don't have to graph the cosine function. It just kind of helps to see why, because of these x-intercepts, why they're vertical asymptotes, and also where the minimum and the maximum, these are minimums, these are maximum points, come from. The same thing is true with the cosecant. It comes off of the sine function, and anytime we have an x-intercept of the sine function, then we have vertical asymptotes, because that would be 1 over 0, which is undefined, and so that's why we put in the asymptotes, always vertical asymptotes. And then it's these branches here that come off of the maximums and the minimums of the sine wave, but you don't have to draw the sine wave. And then we rolled the dice and we came up with our very own secant function, and we rolled the dice and we came up with a cosecant function as well. So we need to finish this one, and then we can write the summaries for the essential questions, and then we can do homework questions. All right, so let's see. The Zoom won't let me in. That is why we leave it right around. Right there. Okay. Anyways, as I was saying, we rolled and we got a function 5 times the cosecant of -2 theta minus pi over 4. And so we factored out the b, as we always do, so we can see what h is without any influence of b. We've given our description. We've started to find the horizontal shift, which confirms what we identified up here. We've got, we found the y coordinate, and we noticed that because of the 0 down here, we've got the vertical asymptote. And then we were in the process of making our table. Okay. All right, so we came up for pi over 2. We've got -3 pi over 8. Let's switch this up. So we've got -2 theta minus pi over 4. That equals pi. And when we get common denominators, we'll have 4 pi over 4 plus pi over 4. That gets us 5 pi over 4. And ultimately, we'll have theta equals, now I need to divide by this -2 here. So that gives me -5 pi over 8. So that's nice, they have the same denominators. There we go. Okay. Okay, so now we've got -2 theta minus pi over 4 equals 3 pi over 2. That's our next value. And that means when we get common denominators, this will be, I multiply 9 pi over 4 plus pi over 4. That gives me 10 pi over 4. And when I divide by this -2, that gives me theta equals -10 pi over 8. I feel like something's not right here. Have I made a mistake? Okay, so 3 pi over 2, when I multiply this by 2, that should be a 6. So this should be a 7. There we go. There's the pattern. So this is negative. I don't know where to put the 7. I'm going to put the 7 right there. That looks terrible, but okay. Because it's -3 and then -5 and then -10. I was like, that's not right. So it's -7. Okay, so 2 theta minus, where are we at here? Pi over 4 equals our last value of 2 pi. And that gets us 8 pi over 4 plus pi over 4 equals 9 pi over 4. And when we divide by this coefficient here, this -2, we'll get that theta equals -9 pi over 8. So writing in those values for our horizontal shifts or transformations, -5 pi over 8 and -7 pi over 8. And then lastly, -9 pi over 8. So you should expect to see some sort of pattern there. It's kind of nice. It confirms that we're on the right track. And then finding the y coordinates. So what is our function? We've got 5 times the cosecant of pi over 2. So that's going to be 5. The cosecant is 1 over the sine of pi over 2. And remember, from our unit circle, the sine of this, so this angle is pi over 2, is going to be 1. So we have 5 times 1. So that gets us a 5 here. We've got 5 times the cosecant. Our next function is pi. So that's going to be 5 times 1 over the sine of pi. And remember, so the y coordinate of pi, this angle is pi, is going to be 0. So we've got 5 times 1 over 0, but we know that's going to be a vertical asymptote because we don't know how to divide by 0, at least not yet. 5 times the cosecant of 3 pi over 2. So again, this will be 5 times the sine, 1 over the sine of 3 pi over 2. And again, so this will be 3 pi over 2 down here, and the y coordinate, because the sine, that's what we're talking about, is -1. So we have 1 over -1, and that'll be -5. And then lastly, we have 5 times the cosecant of 2 pi, which we suspect will be another vertical asymptote. Yeah, so 2 pi is 1 whole revolution, and the y coordinate is 0. So this will be 5 times 1 over 0, which is a vertical asymptote. Okay. Does that make sense, Kings? Can you give me a thumbs up if that makes sense, or chat me a question? Okay, good. Great. Okay, so let's get out our graph. And let's see, what do we have here? So it looks like we need to count by 2, 4, 6, 8, 3 pi over 8. 3, 6, 9 pi over 8. Negative 3 pi over 8. Am I on the screen here? No, of course I'm not. Okay. Negative 9 pi over 8. Okay. And maybe that's better. Then we need to count by ones, it looks like. Should we count by twos? Let's count by ones. Let's have it nice and stretched out. Okay, so here's our vertical asymptote will be negative pi over 8. So that'll be 1/3 of the distance between these two. So right around here, I think. And then negative 5 pi over 8. So this is 3 to 6, so this should be 1/3 that way, or 2/3 the other way. That's pretty good. Okay, and then we also had negative 9 pi over 8 is another vertical asymptote. So using this pattern, so it seems like this is 4 away. So 2, 4. Okay, so we should have one right here. And then one right here. And then one right about here. Okay, so those are the asymptotes. Negative 3 pi over 8 is positive 5, so that's going to be way up here. And then negative 7 pi over 8 is going to be 6, 7 here, negative 5. And then we have a vertical asymptote. So this one should be down here, halfway in the middle of this. Should be about there, negative 5. And that should be 1, 2, 1, 2 right here, 5. And then I think that should be a little bit 1, 2, no, that's about right. And then, so this should be down here. Okay, so our graph, but also we should have one here. So we should have one going this way, and this way, and this way, and this way, and up here. Maybe we should have counted by twos. I had a tangent graph in my mind. Okay, so there is our cosecant graph. And I'm gonna put that up here. And then the domain and the range. I guess I should slow down a second. Are we confident? Are we comfortable with that graph, or do we have questions about it? Do we want an instant replay? What's our comfort level here? So you can either turn on your mics or you can chat me a question. You can give me a thumbs up if you're all good and it totally makes sense. That's exactly what you would have written down. Oh, okay, great, perfect. All right, so we're super confident with this. That's wonderful. Okay, so the domain and the range is the next thing we have to do. So ideas about the domain. So these are always somewhat laborious. You're welcome, English teachers. Okay, so ... we have the union. This is negative 9 pi over 8. And the next one is, what do we say in our table? Negative 5 pi over 8. Union negative 5 pi over 8. if I add 4 to that, I have negative pi over 8 union. Now if I add 4 to this, so negative pi over 8 comma 3 pi over 8 union dot dot dot. So this kind of reinforces the pattern that we noticed that allowed us to draw these other vertical asymptotes. And then the range is negative infinity to negative 5 union positive 5 to infinity. So we have parentheses around the infinities, and we have brackets around the minimum and the maximum. I mean, well, okay. So this is actually the minimum of the sine wave and the maximum of the sine wave here. Okay, so we have negative pi, so parentheses, negative infinity, comma, negative 5, bracket, union, bracket 5 to positive infinity. So that's our domain and range. Okay, so questions about that? We're all good? Do we need more of those, or are we ready for the summary? So chat me if you have a question, or give me a thumbs up if you're ready for the summary. Okay. Claudia, do you have a question you're typing, or are you ready for the summary? Okay, all right, great. So the summary. Let's see, so question 64. So 64 says, what quadrants are the usual thetas in for each tangent and cotangent? So the usual thetas for tangent are in the fourth and first quadrant. The usual thetas for cotangent are in the first and second quadrant. Okay, and then 65 says, how do I graph the secant and cosecant functions? Okay, so to graph the secant, and I think I'm gonna secant and cosecant functions. It's not really any different. The first step is to set b theta minus h equal to 0, right? The second step is to find out what the y coordinate is when the horizontal transformations are all equal to 0. The third step is to come up with 4 additional points using the usual theta. For sine or cosine. Can you see all of this? No. For sine and cosine. And then the fourth step is to graph. Is that okay? Should we say something about the secant equals 1 over, I'm going to change ink. Yeah, let's do that. Hi, B. So the secant equals 1 over the cosine, and the cosecant equals 1 over the sine. So that's that. Now we have time for some homework questions. So tell me, what have you, let me get it's heavy enough to hold that up. Do you have all of the summary? Anybody still need more time for the summary? So let's ask that. Give me a thumbs up if you need more time for the summary. Okay, it looks like we've got all of that. So your homework questions. So I posted all of the tangent, cotangent, all of the tangent and cotangent stuff. And I also wrote the secant and cosecant questions. So, peanut gallery. So questions, really we have the tangent and cotangent is what I really want to focus on. Have I put these in the wrong order? That's weird. Well, anyways, sure did. I sure did. Okay, anyhow. Do you have too many pages here? I just have the pages in the wrong order. Yeah, okay. Probably scan those in the wrong order too. Excellent. Okay, so anyways, tangent. No, I do have something's not right. Tangent questions. That's crazy. Or cosecant, or any of them. Or should we roll the dice and come up with a new one? So yeah, this is time for homework questions. Let me know what you got. Yeah, we can go over a tangent question. Do you just want me to pick one of these? $42, sounds good. Okay, cotangent, perfect. All right. So where do I want to do this at? Right here. Okay. So we had a question about number 42. So 42 says f of theta equals the cotangent of 1/2 theta plus pi over 4 minus 5. Just double checking I copy this down correctly. Okay, so part A asks for the description. So before I can describe it, I need to factor out this 1/2. So we've got the cotangent of 1/2 times theta plus pi over 2. So I want to double check if I distribute the 1/2, I do get what I had before. So I know I'm right there. So the description, it looks like B equals 1/2. So that's a horizontal stretch by 2. Oops, that's not how you spell that word. Yeah, okay, so H equals negative pi over 2. Remember, H has changed sign, so I know it says plus, but really it's the opposite. That's going to be a horizontal shift. Left pi over 2. And then we've got K is negative 5, and that's a vertical shift down 5. So part B, we have to come up with a graph. So the first step is to set b theta minus h equal to 0. So this will be 1/2 theta plus pi over 4 equals 0. So when we subtract this, gives us negative pi over 4. And now we have to multiply by the reciprocal of this coefficient, which is why it's the reciprocal here. So we'll have theta equals 2/1 does give us negative pi over 2, which is what we suggested up here. So that's affirming that we're in the right, going the right direction. Second step, we'll have the cotangent. Now we'll just replace the b theta minus h, we'll just replace it with 0. And remember that the cotangent is really the tangent is sine over cosine. This is cosine of 0 over the sine of 0. So the sine of 0, so this happens to be 1/0, which is a vertical asymptote. Does that part make sense? Yeah, okay, good. Vince, is that good? That makes sense? Great, okay. So we'll come up with 4 additional points. So our usual theta, we'll have our thetas to graph based on those, that b and the h, and then our y coordinates. So 0 we've already used in the first and second step. Just kidding, that's not how this works. Yeah, it is. This is cotangent. So we have 0, we have pi over 4, we have pi over 2, we have 3 pi over 4, and then we have pi. And so here's the, so 0, pi over 4, pi over 2, 3 pi over 4, and pi. Those are the first and second quadrant angles that we want to use. As we said, this will be negative pi over 2, and we found that to be a vertical asymptote based on our work from the first and second step. Now we're going to repeat that work with the first and second step with these other angles. So we have 1/2 theta plus pi over 4 equals pi over 4. So when we subtract that, we'll have 1/2 theta equals 0, because pi over 4 minus pi over 4 is 0. When we multiply by 2, we'll get that theta equals 0. All right, so our next step will be 1/2 theta plus pi over 4 equals pi over 2. And here we'll need to get common denominators. So that gets us 2 pi over 4 minus pi over 4. And so we'll have 1/2, that should be an arrow, 1/2 theta equals pi over 4. And so when we multiply, that will give us, we multiply by 2, we'll have theta equals pi over 2. Okay. Next up, using 3 pi over 4, 1/2 theta plus pi over 4 equals 3 pi over 4. So here we already have common denominators. So when I move this over, I'll get 1/2 theta equals 2 pi over 4. And when I multiply by 2, I'll get that theta equals 4 pi over 4. But since I want to keep common denominators, I'm just going to reduce it to 2 pi over 2 so that I'll be able to see that pattern. And lastly, 1/2 theta plus pi over 4 equals pi. That means we have 4 pi over 4 minus pi over 4, or 3 pi over 4. And so when we multiply that by 2, we'll get that theta equals 6 pi over 4, which is the same as dividing everything by 2, 3 pi over 2. So let's take a look and see what we have here. We said this was 0. We said this was pi over 2. So it seems like we're adding, this is 2 pi over 2. Yeah, 2 pi over 2. And then the last one will be 3 pi over 2. Yes. Oops, just kidding. Okay. So then in order to find these y coordinates, we've got what's our original function here is the cotangent of pi over 4 minus 5. So the cotangent is the cosine over the sine. I'm just going to say pi over 4 right here because that's very squinchy to fit in otherwise. And so the cosine of pi over 4 is 1 over root 2. The sine of pi over 4 is also 1 over root 2. Right? Are we on the same page here? So the cosine over the sine will just simplify to 1. Does that make sense? Yeah, okay. Okay, so we'll have, this will turn out to be 1 minus 5, which is negative 4. Then we do the cotangent of pi over 2 minus 5. It again will be the cosine over the sine of pi over 2. Now keep in mind the cosine is the x-coordinate of an angle that's entirely on the y-axis. So this will be 0 over 1 minus 5, which is negative 5. Remember, 0 over 1, that's 0. Okay, then we'll have the cotangent of 3 pi over 4 minus 5, and that's the cosine over the sine of 3 pi over 4. And remember, so now the cosine is over here. Oops, daisy. The cosine is here. So this is negative 1 over root 2 divided by positive 1 over root 2. And that will simplify to negative 1. So this will be negative 1 minus 5, which is negative 6. And again, that goes nicely with our, that kind of confirms our pattern, right? Like that seems logical. Okay, so the very last thing is the cotangent of 2 pi minus 5. Again, this is the cosine over the sine of 2 pi. And notice that this is 1 over 0, which is a vertical asymptote. So remember, this is 2 pi right here, so it's 1 over the cosine over the sine. So that's how we get a vertical asymptote there. But that does go along with our pattern, so that affirms things pretty nicely. So next up, working with our table here. This all on the screen, pretty close. Okay, so it looks like we should count by pi over 2's. So pi over 2, 2 pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. And I guess we count by 2's here. 2, 4, 6, 8, 10, negative 2, negative 6, negative 10. Okay, so we said there was a vertical asymptote at negative pi over 2. And also at 3 pi over 2. And I think 1, 2, 3, yeah, not quite enough that way. Okay, so pi over, I'm sorry, 0 is at -4. And pi over 2 is at -5. And 2 pi over 2 is at -6. And so here is our curve. Which means we have one here that goes like this. And that continues on that way. And then we also have here and here and here. So we have this piece that's going to go like this. And up like that. So there's our graph. So the next thing that we have to do is just talk about the domain and the range. Okay, there it is. I'm going to trim this so it fits on the page better. So there's that. And now then the domain. That's part C. So the domain here, you have to look at the pattern closely. We have dot, 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 union. This is negative pi over 2 to 3 pi over 2, union 3 pi over 2, comma. So this is 4, right? So 3 plus 4 should be 7 pi over 2. Union 7 pi over 2, comma 11 pi over 2. Union dot, dot, dot. And then the range, our good friend negative infinity to positive infinity. There we go. How's that? Is that better? Any questions? Okay, do you have other homework questions? Are there other problems that you want to see? We can do another homework problem. We can roll the dice for a problem. There's the rest of the tangent, cotangent ones. Do any of those look uncomfortable? Uh, 47, sounds good. All right, so 47. Here. Okay. So 47 says f of theta equals 2 times the tangent of theta plus pi over 3 plus 1. So the description, I've got that a equals 2. That's a vertical stretch by 2. I can see that h equals negative pi over 3. So that's a horizontal shift left pi over 3. And I can see that k equals 1. That's a vertical shift up 1. So hopefully all of that is what you expected and makes sense. Part B, we have to start graphing. So when we set b theta minus h equal to 0, this will confirm the horizontal shifts we identified. So theta plus pi over 3 equals 0, and theta equals negative pi over 3. So this matches with what we said. So we know we're on the right track. The second step, if you plug in b theta minus h and set it equal to 0, we'll get the y coordinate for that value, that x value. So I've got 2 times the tangent. I'm going to plug 0 in right here, plus 1. Now remember, the tangent is the sine of 0 over the cosine of 0, plus 1. And so the sine of 0 happens to be 0. The cosine of 0 happens to be 1. But this is just equal to 0, so that gives us 1. So 2 times 0 is 0, 0 plus 1 is 1. Okay. Next, we'll come up with 4 additional points. Now remember, with tangent, the usual theta is the 4th quadrant and the 1st quadrant. So we just need to, that's something that can be a little bit hard to remember. So we go with negative pi over 2, negative pi over 4, 0, which we've already found the values for in our first and second step. Okay, with 0 in the first step, we found this to be negative pi over 3. I'm glad I'm using pencil because we will want those denominators to be the same, so maybe we have to change that. But coming up with the horizontal values, we'll use theta plus pi over 3 equals negative pi over 2. And the common denominator situation is theta equals, this will be negative 3 pi over 6 minus 2 pi over 6. So 3 pi over 2, when I multiply this by 3 over 3, I get negative 3 pi over 6. And pi over 3, when I multiply it by 2 over 2, that's how I got the negative 2 pi over 6. So the denominators are the same. So this will be negative 5 pi over 6. Okay. So that'll be that value right there. When I say theta plus pi over 3 is equal to negative pi over 4, I'll get theta equals, what happens here? Negative, so 12 would be our common denominator. So negative 3 pi over 12 minus 4 pi over 12. And that gets us negative 7 pi over 12. So that means this one would be negative 10 pi over 12 when I multiply the numerator and the denominator by 2. So our last one, our next to last one, theta plus pi over 3 equals positive pi over 4. And that gets us theta equals, again, this will be 3 pi over 12 minus 4 pi over 12, which is negative pi over 12. And so lastly, theta plus pi over 3 equals pi over 2, again with the common denominator stuff. So should we just go for the 12 right now? That means we multiply, we've got 6 pi over 12 minus, this will be what, 4 pi over 12? I'm going to double check my work because I don't normally do that. So 6 over 12, and then this would be 4 over 4. Yeah, okay. So we get 2 pi over 12. Okay, so this middle value, we want to make negative 4 pi over 12 because we had negative pi over 3. So negative 4 pi over 12 there. And this one was 2 pi over 12. Negative 10 pi over 12. Negative 7 pi over 12. So it looks like we're adding 3 every time, which means this should be negative pi over 12, and it is, so that's good. Again, feeling confident about this. If I had to do this on a homework quiz, I'd be feeling pretty good about my answers right now. Everything seems to line up nicely. Okay, so now our function is 2 times the tangent. Our usual theta is negative pi over 2, and then we have a vertical shift up 1. But it turns out, remember that the tangent is the sine over the cosine. So the cosine of negative pi over 2, remember that's the x-coordinate of negative pi over 2 is 0. So we can't have that in the denominator. That means the entire thing will be a vertical asymptote. Does that part make sense? Okay, that's good. Claudia, does that make sense? Okay, great. All right, so we have a vertical asymptote here, which is what we anticipated. So that's what should be happening now. Then we'll have 2 times the tangent of negative pi over 4 plus 1. And remember, again, it's the sine over the cosine. So we've got the sine over the cosine of negative pi over 4 plus 1. So the sine of this, this is negative pi over 4. The sine is negative. The cosine is positive. But their absolute values are the same amount. So we know this will be 2 times negative 1 plus 1. So negative 2 plus 1 is negative 1. And then we already have this one from our second step. So next we've got 2 times the tangent of pi over 4 plus 1. So again, the tangent is the sine over the cosine. Pi over 4. But that's going to be 1, right? Because now up here in the first quadrant, they're both positive. So 2 times 1 plus 1, that gives us 3. Which makes sense. So this is adding 2, and then this is adding 2 again. And then we can estimate 2 times the tangent, or predict rather, that pi over 2 will give us another vertical asymptote. Which it will, because this will be 2 times 1 over 0. And that is definitely a vertical asymptote. Is that okay? Questions there? Oh, sorry, you can't see all of that. I'm gonna work there. So that makes sense? Everything there, what you expected? Great, okay, great. All right, let's get a graph. And let's see if I put this here. I gotta put it here. All right, so what do we want to count by here? This is sort of bonkers. 4, 8, 12, 16. We don't need that far. We need to 10. 3, 6, 9, 12. We'll go by that. So 3 pi over 2. 6, 9 pi over 2. Negative 3 pi over 2. 6, negative 9 pi over 2. Okay. So that's not totally awesome, but and we will count by ones here. Let's see. So negative 10 pi over 12 is the vertical asymptote. So that should be 1/3 of the way here. I'm going to estimate around there. And then 2 pi over 12. So that should be here. And we said it was, what was the pattern we noticed? Was it 4? That we're adding 4, we're adding 3 every time. Yeah, so but between here and here, that's going to be negative 10. That'll be 12. That makes sense. So this is 2 plus 12 is 14. So that'll be off our graph. So those are the only vertical asymptotes we can fit based on the units that we've chosen. And negative 7 pi over 12 is negative 1. So that's going to be right around here. Negative 4 pi over 12 should be positive 1. So that should be here. And negative pi over 12 should be right around here. So here's our graph. it comes up there, and here's the other end of it coming down over here. Something like this. And so repeating that pattern, we've got here, we've got here, and then we have there. Yes, yes, okay. So again, this goes off, and this will approach the asymptote from the right. So there's our graph. So questions about that one? Okay, no questions. Let's talk about the domain and the range, because I know those are a little bit still kind of sketchy, and then that'll pretty much be the ball game. What's this way? Yes. Okay, so the domain is, it goes from ... union. We have a negative 10 pi over 12, comma, and then 2 pi over 12, union 2 pi over 12. Now we said the distance here was 10 plus 2 is 12. So 2 plus 12 is 14 pi over 12. Union 14 pi over 12, comma, that should be what, 26 pi over 12? And then the range goes from negative infinity to positive infinity. There we go. Okay. So I should let you go. Remember, there's a homework quiz on tangent and cotangent that's on Edmodo. So that's due Sunday at midnight. Please don't forget about that. And we will have class next week, Tuesday and Thursday. And then on Monday, we're supposed to have a final, but we don't have a final planned. So really, I think on Monday, I would just like to have as many people log on as possible and tell me what they liked and didn't like about the distance learning, so that I can have some positive, some input as we figure out what's going to happen with the fall semester. Okay, so have a great weekend, and I will see you on Tuesday. Take care.
Thank you.
You're welcome.